Hey, chemistry students. Mr. E here. How you doing? Hope you're doing okay on this online learning experience. Just keep up with it. We'll be done before too long. Okay, so this video, I'm going to try to help you out a little bit here and explain for you, if you're interested, in how to do some math calculations with the gas laws. This week, we're going to take a look at two of the laws, Boyle's law and Charles' law, and they deal with volume and pressure and temperature. And those are part of the factors that affect gas pressure from the last lesson. And think about it, right? If you have a gas and you make the container smaller, those particles in the gas are going to hit the sides of the container more, and so the gas pressure is going to go up. Likewise, if you have a container and you heat up the particles inside, they're going to have more energy, they're going to bop around more, they're going to have more collisions with the sides and walls of the container, and the pressure is going to go up. So that's a relationship right there. When you change the temperature or the volume, you change the pressure, or if you change the pressure, you change the temperature or the volume. So we can do some math with those calculations. So this week we're going to deal with two laws, Boyle's and Charles'. Next week we'll take a look at another law by a guy named Gay-Lussac, and also we'll take a look at density, which is the idea about how much mass you have in a volume, and calculate that out. So we'll be doing some math for another week here after this, and then we'll move on. Okay, so I'm going to work some problems here on a piece of paper, and basically I'm going to follow along with the 2 pages of the lesson, lesson 4 this week on the gas laws. Well, the first of the 2 gas laws we're looking at this week is Boyle's law. And Boyle deals with pressure and volume. It's an inverse proportion, which means that when one of the values goes up, the other one goes down. So if the pressure goes up, the volume goes down. If the pressure goes down, the volume goes up. So inverse. Think about it too. If you put more pressure on it, you got a bigger number here, the volume's going to get squished, it's going to get smaller. But it's proportionate. So if I push down 3 times harder on the pressure, my volume's going to get 3 times smaller. Okay, here's the equation for Boyle's law, right there. The first event, the first pressure times the first volume equals the second pressure times the second volume. When we're dealing with pressure problems, there are lots of different units to use. We are going to deal with 2. The first one, atmospheres, is what the pressure's like on a normal day at the beach at sea level, basically. And millimeters of mercury is the other one. That's commonly used in barometers. Volume, there's 2 units, milliliters and liters. And milliliters are just smaller. There's 1,000 milliliters in 1 liter. What we're going to use right now is atmospheres mainly, but we're also going to do some millimeters of mercury conversions, and we're going to just use liters. So pressure and volume must be in the same units on both sides of the equation. And we have 2 different units here, atmospheres and millimeters of mercury, and they use different size units. So 1 atmosphere takes a lot of millimeters of mercury. So there's a conversion we put them into. It's called an equivalent. And it looks like a division problem, but really it's saying that 1 atmosphere is equivalent to, or is equal to, 760 millimeters of mercury. You could flip that over too, but we're not going to need to do that, at least at this stage. So here we've got a problem. I have 1,104 millimeters of mercury, and I want to put it into atmospheres. Well, every atmosphere is equal to 760 millimeters of mercury, and I can see I have more, so I know I'm going to have more than 1 atmosphere here. The way we set it up in science is kind of nerdy, because instead of equal, we do this. They say put a times there, and then you put the equivalent there. And with an equivalent, what you do, this is kind of like it's over 1 right here, and you set it up so that the unit up above here, whatever the unit is, matches the unit down here, and then they'll cancel. So that tells me that I want to write this equivalent with the millimeters of mercury down here and the atmospheres up here. And then I just fill in the numbers, 760 and 1.0. And so that's going to give me 1.5 atmospheres. Now the way you can set the problem up as you go along is just do this. 1104 divided by 760 equals some number, but remember to put atmospheres on there. Well, let's do some problems that are on the module for the week. Here's Boyle's law, P1 V1 equals P2 V2. The information is given to me in this problem. What I like to do is write down on the side there, on the left side of my paper, what I do and don't know. I need to know 3 of the 4 in order to solve for the 4th one. So here's what I have. I have my first pressure is 123 atmospheres, and my volume is 2.3 liters. I don't know what my second pressure is, but my second volume I know 3.4 liters. So I know that what I've got going here, this times this has to equal this pressure times this volume right here. So I have to solve for the pressure. Another thing I know is that my volume went up. So just to keep in mind, to see if my answer is correct at the end, if my volume went up, the pressure must have gone down. So this number, P2, should be less than P1. So start out, write down what you know, and substitute it for the symbols. So P1, and I'm going to use the units here, 123 atmospheres times 2.3 liters is equal to X, but I don't use X, I call it P2 because that reminds me that I've got to put a unit on that answer that I'm looking for pressure times 3.4 liters. So that right there, that's my setup, by the way. So if you're showing your work, that's what you really have to do is show that right there. You don't have to show the rest of the steps, but we're going to do that, of course, as we're learning this. So the next thing I'm going to do is, this is a step that we do in science for canceling the units, like I showed in the previous example. You don't have to do this every time, but I'm going to run through it right now. So what I would do, I want to get P2 or X by itself, so I divide both sides by 3.4 liters. So here's how that goes, is I have 123 atmospheres times 2.3 liters divided by 3.4 liters gives me my pressure. One reason we do that is it directs us how we want to set stuff up, whether we multiply or divide or whatever, because I have 2 liter units, and a liter unit on top divided by a liter unit on the bottom cancels. So they go away, and that leaves me atmospheres, which is great because that's what I want to find, is the pressure in atmospheres, and that tells me that that needs to be a division problem. So now I'm just going to write it again. And what I actually have 123 times 2.3 divided by 3.4 is equal to P2. And that's really all you have to write right there. Multiply those together, I get 282.9 divided by 3.4 equals P2. And when I divide that out, I get 83.2 watts atmospheres equals P2. And so that's your basic setup right there. And that's showing you how you cancel the units. All right, let's go on. We'll do the second problem here. Change colors. Now, example number 2, you have to read in here. So that's just a little bit tougher, but really not too difficult. You just have to go through and look at the problem and decide what are the factors, right? Because remember, the equation is P1 V1 equals P2 V2. So usually it's in the first sentence. You want to keep them together. You have to understand which two go together. So here it tells us a gas has a volume of 285 liters. Hey, that's the first volume I see. That's probably going to be V1. And a pressure of 115 atmospheres. So there's my P1 right there. Calculate the new volume. New, calculate. All right, that's what I want to find. That's my V2. That I don't know. But I do know that the pressure, if the pressure increases to 2.03 atmospheres, so that's my P2. So let's just write down what we have over here. All right, so I've got my P1 and my V1 and my P2 and my V2. My P1 is 1.15 atmospheres. My V1 is 2.85 liters. My P2 is given to me here at 2.03 atmospheres, and my V2 is what I'm looking for. So we just set that up. You don't have to rewrite P1, V1, P2, V2 at the top every time. I do want the setup, I want the units on it. So you're gonna write 1.15, atmospheres times 2.85 liters equals 2.03 atmospheres times V2. Sorry about that. Also, as you may have noticed, I use parentheses. I don't use X's. Now we know that we're going to bring that ATM over there, and those are going to cancel the atmospheres and leave us liters, which is what we want for volume, okay? And that's the way I was taught to do my algebra way back in the dark ages. Now a lot of times it looks like math teachers have you solve this number and then divide that number, and that's fine too. If I was going to do that right now, I would write 3.28 is equal to 2.03 times x, but again, I'm going to call that V2. Just helps me remember. You can put x if you want, but remember you have to put a unit on it. So bringing that little bit of algebra over there, I've got 3.28 divided by 2.03 is equal to V2. And when I divide that, I get 1.62, what's the unit? Liters equals V2. So that right there is my answer. Let's double check. The pressure went up, the volume should have gone down, and sure enough, I see that it dropped. Probably the right answer. All right, we're gonna go on. I've got one more problem here that was actually on the, here they are, okay. And this one takes a lot of reading, all right? But basically, it's the same thing. This is typical science right here. This is typical having Mr. E for science right here, because you gotta read a jillion words. Here's what I said. I'm at the beach where the air pressure is 1.00 atmospheres with a balloon containing 3.44 liters of air. Well, there's my first set of conditions right there. I'm at the beach, and this is my P1, my pressure 1. I have a balloon containing 3.44 liters, so there's my V1. So I take the balloon up to Mount Baker, and there the air pressure, so that's telling me my new pressure. This is P2 right here, and so here's P1, and there's V1. What is the new volume, V2? I don't know. So let's write down what we know. P1 is equal to 1.00 atmospheres. V1 is equal to 3.44 liters. P2 is equal to 159.6 millimeters of mercury, and V2 is equal to, I don't know. Now here's our situation. I want the answer in atmospheres, so I have to convert this right here. Now I could set it up, and really it would be times 1 atmosphere over the 760, but I'm just going to cheat a little bit here, I guess. I don't know if it's really cheating, but we get it. So we're going to draw that across there, because what do I need to do to get atmospheres? I need to divide my millimeters of mercury every time by my equivalent, which means divide it by 760 millimeters of mercury. And so that's going to give me 0.21 atmospheres. And why am I doing that? Because remember that 1.0 atmospheres is equal to 760 millimeters of mercury. And so I just put that there and save just a little bit of a step, okay? So we're gonna finish this out right here, and I'm gonna write out what I have. 1.00 atmospheres times 3.44 liters is equal to 0.21 atmospheres. Good old Mr. E running out of room on the edge right there, V2. So there it is. Well, I can pretty easily do that. 1 times 3.44 is equal to 3.44, and that's going to be equal to 0.21 atmospheres, basically, times V2. So I'm going to bring that over here, and I'm going to have 3.44 divided by 0.021 gives me V2. And when I divide that, I get a pretty big number compared to what I started with. 16.4 liters equals V2. Wow, how'd that number get so big? Well, look what happened. I went more than 4 times smaller on my atmospheres, my pressure, so I let off on the pressure. What happened to the volume? It got bigger. Okay, so there you go. Those are the examples for Boyle's Law. So check those out. Try the practice problems, take the quiz, make sure you get 50% or do all the retakes on it. And there'll be another video on Charles' Law.